In 4.3b, we're going to still be showing or proving that triangles are congruent. We're going to use what's called the angle, not included, side, triangle congruence. But first of all, let's kind of look at the ones we've already done from last week. We said that we can get 3 pairs of corresponding sides to be congruent, and if so, we can stop and say the triangles are congruent. Remember, sometimes we had to do what I call add our brain to it. If there was a shared side, we would cite the reflexive property. If we were told there was a midpoint, we'd say, oh, these are congruent by definition of midpoint. But if you are given or can get all 3 pairs of corresponding sides congruent, you can stop and say your triangles are congruent. Same with side, included angle, side. And from Friday, our angle, side, angle. Thursday, actually. So these are our 3 ways, and we're going to be adding our 4th. But let's go to slide number 34 just so you can get a visual. Here's our side, side, side. Here's our side included angle, side. It's the angle smashed between the two if you were on a walk. Somebody said it's like the Pac-Man. Then we had our angle, side, angle, where the side was the road between the 2 angles. And today we're going to be doing our angle, angle, side. Couple things to note here. This bottom one in the bottom left we'll be doing in another section. And we've said that there's no SSA or ASS congruence. And you can see why over here with this picture. We've got an 11 and a 6 with a 30-degree outside angle, and an 11 and a 6 and a 30-degree outside angle. And that 6 could have gone anywhere. And so we are not forced to have congruent sides when we have angle, side, side. Also, up in the top left here, I want you to type in that there's no angle, angle, angle. Just getting 3 pairs of angles to be the same is also not enough. So let's go work with our 4th method, the angle, angle, side, which we'll call AAS congruence. Note, this side is not included between the angles. Okay, so you got to make sure you don't goof it up with angle, side, angle. The side is not included between the angles. So here is a blue triangle, ABC, and a pink one. And we've got angles in the bottom left, A and K being marked congruent, B and L also being marked congruent, and then the side not connecting them marked congruent. So this is kind of sweet because we have all the information we need. When we have that, we say it's all given, or we say it's all marked on the diagram. That's the best case scenario. We would say these triangles are congruent by angle, angle, not included side. And then if we're asked to write a congruent statement, we put that on our vocabulary sheet last week. We said that that's when we match our corresponding parts. I started with the pink one, and I started with angle K. So on the blue one, you have to match it to its corresponding part, the one with the double arc in there at angle A. And then I chose L, so we must choose B, and then lastly C. And that right there is called a congruent statement. We may need to do what I call adding our brain to get some of the missing parts. So you'll notice up here, only 1 pair of sides was marked. DB is for sure congruent to CB. But the rest of it, I have to use my brain and my reasons. I see that X in there at the center, and we're good at noticing that that's when we're going to cite the vertical angle theorem. So I know I've got some angles in there congruent by the vertical angle theorem because I saw the X. So I can say ABD is congruent to, let's type it in and match our corresponding parts, EBC by vertical angle theorem. That one's really easy to spot. And then we talked last week about how these runners that indicate parallel lines, these little black solid arrows, are almost always a hint to use the alternate interior angle theorem. Sometimes corresponding angle postulate, but mostly we want to steal some alternate interior angles. We can put the pink dots right here for an angle, angle, side argument, or also alternate interior are down here for an angle included side angle argument. But because we're on angle side today, I'm going to mark this pair of alternate interior angles the same. So I have marked angle DAB, congruent to angle, match the corresponding parts, CBE, CEB, this bottom one in the pink, by alternate interior angle theorem. Now the triangles are congruent by our new guy, angle, angle, side. Let's highlight that. So again, it's still got that same flow that we've put on our workflow sheet. We take a look at what we're given. If we have it all, that's great. Usually we don't. Then we use our properties to add some missing sides and angles. Our end game is to get one of these four, for now, situations going so we can stop and say the triangles are congruent. So let's go to our next example here. This is a best case scenario because with the markings given, I've got angle, angle, side. I've got purple, angle, blue, angle, red, side, matching purple, blue, red, angle, angle, side. So I could just stop and say that triangle ADB is congruent to triangle CDB, match those corresponding parts. Oops, sorry. Triangle C, looks like I need to stretch that text box out a little bit, huh? Let's get rid of that. Triangle CDB by our new guy, angle, angle, not included side. So that's nice and easy, but I want to talk about some old reasons as well. What if I said D was the midpoint of side AC? D is right smack in the middle. Then I could use that to know that the length of AD has to be equal to the length of CD, or the segments are congruent. And I would say by definition of a midpoint. So let's type that in. By definition of a midpoint. That's a pretty common one, right? And when we add stuff, I think I like to put it in red. What if I told you that what if side or segment BD bisects angle B up there? That means it cuts it into two equal pieces. So then I could say, well, angle ABD up at the top has to be equal to, because bisect means to cut into two equal pieces, CBD, also up at the top. They would be congruent. I used an equal symbol there, but no, we would state that they are congruent. Now, also, I could get those angles up there with the third angle theorem. So again, don't forget all of our reasons. Let's go practice deciding if we have enough information to prove triangles are congruent by our new congruence criteria in 4.3a and b. 4.3a was angle included side angle. So let's go take a look at the diagram. I do have matching pairs of angles at T and U, another pair at H and N. The side smashed between them is TN and UH. Those two sides clearly aren't marked congruent. There's no dashes on them. But do I have a reason for saying they're congruent? Are they shared? No. Was there a midpoint? No. There's really no reason except that they look the same, but you can't go by looks, so this would be no. We have no way to get the included sides congruent. So don't go by looks. You have to have reasons and logic. Okay? Now let's go look over here. Is this enough for angle, angle, side not smash between them? So let's go walk the triangle. I've got angle, angle, side not smash between them. Here's the corresponding one to where I started. Angle, angle, side not smash between them. This is a definite yes, and I didn't even need to add my brain to the picture. Next up, we watched this little video, so I suggest you click on it. It's really good. It's got some great animation, and then we wrapped it up with this proof. So we're given that we've got some perpendicular lines, so a right angle's been put in there, so I think it's safe to say that it's given that these two angles are congruent. T T is the midpoint of PR. Looks like I've got a, there. I have a box over the top of this because we're going to be dragging it. So it should just say T is the midpoint of PR. And I have to prove the triangles are the same. So let's go kind of talk through a plan for this. First of all, we clearly only have one pair of angles because of the right angles there in at Q and S. So we have to look at that and say, what do we see? I see that X. See the X in the middle. That's going to trigger vertical angle theorem in at T. Okay, so these angles in here at T are going to be congruent by the vertical angle theorem. So I know I'm not going to go a side, side, side. Why would I if I just got a pair of angles, two pairs of angles? Next up, can I get any sides? Because yeah, I could get the third angles congruent by the third angle theorem, but there's no triple A or angle, angle, angle. But back in the given, I was told that T is a midpoint of PR, which means it slices it into two equal pieces. So I'm going to use the fact that I know what a midpoint is. I know what midpoint means. So my brain gets to say that I know from P to T is actually going to be the same distance as from R to T. Now let's see what I've got here. I've got side PT congruent to side RT. And then I've got two angles. Now I have to walk the triangle to decide if I go angle, side, angle, or angle, angle, side. So let's hop on this right angle at Q. I have angle, angle because of the vertical, side because of the midpoint. So we're going to end in angle, angle, side. Right here by angle, angle, side. What do I put first? I'm going to drag my given in there. Okay, how do I know that? And we're just going to type in over here, it was given. Now for these two things I noticed, I had some angles congruent by the vertical angle theorem. What were they? Remember, we can't call it angle T when there's two in there. We have to call it Q to T to P or P to T to Q with an angle symbol in front of it. Congruent to match corresponding parts S to T to R and an angle sign in front of it. Remember, if I started with Q, the right angle, in my congruent statement, I have to start with S. And that was by the vertical angle theorem. We spotted that X in there at the middle. What else did I say? I used the fact that I knew what a midpoint was. So I know P to T, the segment, lengths are equal, segments are congruent, is congruent from R to T. So those segments are congruent. By what reason? I knew what a midpoint meant. So we'll write definition of midpoint. All right, so the proofs flow kind of nicely. You just kind of have to mark up your diagram with what was given, add your brain to it, and then we're in hopes of getting one of our four. Let's go back to them here. One of our four, but today, so no on your worksheet, you're going to be gearing yourself towards angle, angle, side because that was today's theorem of the day. But we also now have four. So on your quiz coming up, you're going to have to decide which of the four, and we'll practice that at another time. So the homework is worksheet 4.3b. If you were absent, its PDF is in Schoology. Have a good one.